Hello, my name is Marihan Amin, and I'm a firmware developer at Introspect. In this video, I'm going to be introducing the basics of how to use our SoundWire test tool. So first, I'll start by opening the Pinetree software. Then, under the list of form factors, I'll select the SV6E-X SoundWire. In this demo, I'm going to preload an existing test, but you should be able to start a fresh new test if you want to. As you can see here, under the Components tab, there are 6 preloaded components. The highest level component is the SoundWire bus, where you can specify the high voltage level of the SoundWire interface. In this demo, we're going to be experimenting with 1.2 volts. On the SoundWire bus, you should also be able to specify the number of ports. The SV6E-X can support up to 4 independent devices, but in this demo, we're only going to be using ports 1 and 2. We'll instantiate a manager device on port 1 and a peripheral device on port 2, and then we'll be connecting them in loopback. Every manager device has to be attached to manager params, and the manager params is a component that is used to define the behavior of the manager, where you can specify many attributes such as the clock frequency of the SoundWire interface, as well as the clock to data skew, and the frame dimensions, and the data sample size and sample interval. Every peripheral device must be identified by a unique device ID, and the device ID is programmable through here. And similar to the manager, every peripheral device must be attached to peripheral params, and the peripheral params is an independent component which is used to define the behavior of the peripheral. On the right here, this is the procedure tab. We'll first start by instantiating the manager device, then a peripheral device, and then we'll start by exercising some basic SoundWire functionality. We'll start by performing a bus reset, then we'll go through all the steps of synchronizing a peripheral, then inquiring about its ping status, then enumerating the device in order to give it a dynamic address. Then we'll attempt to send a write frame with valid payload data, and then we will go through how to request an interrupt request. Now, if we hit run, we should see the results log over here. So this is the ping results of the first ping request. So as you can see here, it will be based on the device number, and then the status will be reported per device. So if you're already familiar with the spec, you should know that device number 0 is used by any device that has not been enumerated yet. So after the synchronization stage, the peripheral will report that it has attached to the bus on device number 0. After the peripheral attaches, the manager will go ahead and enumerate the peripheral, and we'll be able to see here that the peripheral was assigned a device number 1, and you should also be able to see the device ID of the enumerated device, which should match with the device number programmed here. After that, the manager will send another ping request to get the new ping status. So you'll be able to see here that the peripheral device reports that it is still attached on the bus, but this time on device number 1 instead of 0, which is its new device number. After the device is synchronized and has been enumerated successfully, it will send a write frame which carries a valid payload bytes. In the spec, a frame is partitioned into 2 independent parts, the control word and the payload bytes. The control word can have one of 3 opcodes. The first opcode is the ping command, which we've already demonstrated earlier. There are 2 other types of opcodes, which is a write register and a read register. Here, we'll experiment with a read register opcode, and we'll attempt to read from device number 1 the value stored in the register address hex 46, register hex 46 carries the device number of the peripheral. So here we'll attempt to get the data written to the peripheral by using the get payload write data method. And the peripheral returns the right data that the manager has sent to it, which should match with whatever bytes that the manager has sent. In addition to this, the peripheral also returns its device number, which is the value stored in register hex 46. Finally, the peripheral here will request an interrupt, and this request interrupt method should be expressed later when the manager sends a new ping command. So when the manager sends the new ping command, we should be able to see that the peripheral has requested an interrupt on device number 1. This now comes to the conclusion of this video. Thank you for watching this video.